Calculus! This is AP Calculus, lesson 3-7. I'm not going to do the crazy intro, but it is still a good day. We're all switching places with teachers. I could be a student teaching. I could have my voice break maybe. We have lesson 3-7. Here we are in our unit guide. 3-7, you'll notice that we're 2 lessons away, including today's lesson, from finishing the unit, and we have 2 self-checks, pre-test, and the fix-up. So let's go ahead and get started. You'll notice that the setup is basically all blank. The front and back, there's only an equation, because all of this you should know already with a little bit of new stuff that I'll be teaching you. So the first thing that we're going to do is the same thing that we did yesterday. We're going to draw the x-axis, do those same exact steps. So let's go ahead and do step 1, draw that x-axis. We're going to find the derivative after we draw the x-axis. The first step is always drawing the x-axis. And then, of course, we need to find the CVs. Let's just review for now. And to find CVs, Arrow pointed out that we need to find the derivative. So, Arrow, you want to do the derivative for us? What is f prime of x?
F prime of x is 1 over 3x squared times 6x.
What do you guys think? Yeah? She got it?
So that simplify that to 2 over x.
Be 2 over x. We're all in agreement? All right, cool. What do I do next?
You set the x, the f prime of x to 0. Yes.
Yeah, and to be more specific, I'm going to label this as finding the critical values. Because while your step is correct for half of the critical value, setting it equal to 0, it isn't correct for the second half.
Set x equals to 0 so it doesn't exist.
Because it's a fraction, but you don't always.
Yeah, so this is what I'm going to add to our notes, just going off of yesterday, is numerator set equal to 0. That will find something, and denominator set equal to 0, that will find the other half of the critical value. So why is setting the numerator equal to 0, why is that finding critical values? What are you really finding? Where f prime is equal to 0 or does not exist?
Equals to 0.
Yeah, so f prime is equal to 0, and where the denominator is equal to 0, that's where f prime, exactly. So when I set the numerator equal to 0, I get 2 equals 0. You could never have that happen, so don't worry about it.
But you could do 2x. You could just write this as 2x to the negative 1.
Even if it was 2x to the negative 1, you can still never get the numerator equal to 0.
But it doesn't have to be the numerator, because if x equals 0, 0 to the negative, oh, because it would be,
Even if you do
yeah,
it
you
the
can
long
do
way,
0
it's
to
the
a
same.
negative power.
Yeah, exactly. Because then you're dividing by 0. Yeah, good point. And then, so you can't do this one. You can do this one. If I set the denominator equal to 0, therefore we get x equals 0. There it is.
So there are critical values, but there aren't relative extrema.
We'll see. That's good that you're already looking ahead. Oh, whoa, I didn't know I could change the color like that. Did you guys see that? I just learned now that I can change the color of all of this stuff. I could change the numerator and denominator to blue just by clicking on blue over here, but I'm not going to do that. I just realized I am always forgetting to give myself extra space over here. All right, so we're going to graph that critical value. There it is, boink, at 0. And what are we going to do with this 0? We're going to do something above it from the notes yesterday. Yep, label it critical value. That's a CV.
We didn't really do it yesterday, did we?
Yeah,
We did, yep.
This isn't the most important stuff, but
It is important today because now we're going to be finding multiple different types of values on this x-axis. And we need to know what 0 is. Is it a critical value? Is it an f-min, f-max, f-relative extrema? It does matter now. So that's a critical value. And then we need to go on to our new notes. Our new notes are, oh, hold on, we haven't finished the old notes. Old notes say we have to find critical value in these other 2 things. What are those other 2 things?
f increasing and f decreasing.
Exactly. So to find f increasing and f decreasing, I'm choosing some point out here, and it doesn't matter what it is. What's a good number to choose?
Yes,
1 would be on the right-hand side, but negative 1 would be on the left-hand side. When we plug in negative 1 to, am I plugging in negative 1 to f of x or f prime of x? Okay, so I'm plugging into this equation here, Is it going to be a negative or a positive?
Negative.
It's a negative, so we're going to say negative. And therefore, what do we say about this interval up here?
Decreasing.
F decreasing. All right. And what about when I plug in 1 to f of x?
It's positive.
Positive, therefore,
It's F increasing.
all right, perfect. We got our review in. Go on to the next page of my notes. Huh, that's weird. My notes are missing a page. Okay. So from there, you can either do this one of two ways. You can either do your new stuff, your relative extrema, f min, f max, all on the same number line, or you can have it on a separate number line. It'll get messy if it's on the same number line, but you only have to draw one number line. So I think I'm just going to try it all on the same number line. If you guys think that's a bad idea, we can start doing it on a separate number line from now on. All right, so if I want to find f relative extrema, what is the definition of that first of all?
Prime sign change.
Okay, and therefore f prime sign change, f minimum is a subtype of f relative extrema, which is what?
When negative goes to positive.
When what goes from negative to a positive?
The F prime.
Yep, and then arrow f max is
When F prime goes from positive to negative.
exactly. All right, so now we need to figure out if this critical value is a minimum or a maximum. It's kind of straightforward there.
It's a minimum.
It's a minimum. Why, Ben?
Because as x increases, it's the slope of
It's got,
f is negative, and then it becomes
yeah, it's
positive
got
at 0.
negative and positive written.
Yeah, I mean, you're looking at these. Yeah, exactly. It goes from a negative to a positive. Therefore, this CV is also above this. It's going to be an F minimum. All right. Is there anything else that we need to say about this one? Yeah, that's all we can find because we don't have any F min, F max. So let's go ahead and write them all down because then we're going to the backside. So FCV, F minimum, F maximum, and F relative extrema, and F, oops. We need to do all the ones that are up here, F min, F max, F min, F max.
Why are there two f min and f max?
I don't know why I put two F mins and
You
F
have to
max.
do that.
We needed f increase.
That's what I was supposed to do up here, yep. Yeah, that's a teacher error too. This should be increasing and decreasing. I don't know why it does that. Scroll back up and down. So this is F increasing, F decreasing. And you can, if you don't want to erase, you can just do them reverse. So F min and F max. So now we can find 6 things after these notes. Double the amount. So our critical value.
X 0.
There it is, x equals 0. F is increasing where?
When x is greater than 0.
When x is greater than 0. And another way of saying that in interval notation is what? Someone knew?
0 to infinity.
From 0 to infinity. And let me back up here. From 0 to infinity. Do I do square bracket or parentheses for the 0?
Parentheses.
And what about for the infinity?
Parentheses.
Good, yep. F decreasing, where is that?
Negative
Yep.
infinity to 0. I mean to negative, yeah, to 0.
Negative infinity to 0 using the same parentheses and an inequality notation arrow. How do I do that?
X is less than 0.
X is less than 0, perfect. F relative extrema, anyone?
X equals 0.
It's a minimum.
X equals 0.
And there's no max, right?
Yep, F max is, there's nothing. F minimum, we have X equals 0, and F max, you just do a line, or you can say it does not exist. I just do a line because it's faster.
So would the graph of f be a parabola?
Would a graph of F,
Because it's a quadratic, but it also has the ln.
yes. So this one would look, if I graph this, it would look roughly like just the natural log function, but slightly, it's going, why does it lag? We're going through a different intersection, but it's basically the natural log function. Because when you think about how powerful functions are in terms of how much they affect other functions, the most powerful in terms of making them go upwards toward infinity is something to the power of x, like 3 to the power of x. That goes towards infinity really, really fast. Next fastest is something like quadratic, so something to the power of 3, x to the power of 3, x to the power of 4, stuff like that. And then you have linear after that, and then you start getting slower and slower towards infinity. So you're talking about the reverse of quadratic, which would be square roots or cube roots. And then the slowest out of everything is the inverse of something to the power of x. 3 to the power of x, when I take the inverse of that, it looks more like natural log function. So the inverse of e to the power of x is natural log to the power of x. So natural logs, they go towards infinity the slowest. Even if they have a bunch of stuff on the inside, they still are really, really slow. It doesn't even matter. Like I could have, well, I guess if you have something like 2 to the power of x, then they'll cancel each other out. But even a quadratic is not as powerful as a natural log. The only thing that would make this slightly linear is if I had something like x to the power, or sorry, a number to the power of x. And just playing around with Desmos is the best way to figure those out. All right, questions about example 1? All right, let's try example 2. You guys tell me what to do now.
Draw the x-axis.
Draw x-axis. That's step 1. Give yourself room this time, Mr. Sindel. Oh, I forgot to do something on my last one. I'll scroll back up, see if you guys want to get the extra credit point.
You didn't draw the x.
I didn't draw the x. Yeah, it has to be labeled with an x. That's the x-axis, not the y-axis. Log in your extra credit tracker. Oh, and if you didn't log the 10 points for doing the stage, make sure you do that too, Michelle. And I'll sign that off today. All right, I drew the x-axis. What's my next step?
Get f prime.
All right.
Set to 0.
And I want to skip a ton of space. Let's go down here. F prime of x, and we'll set it equal to 0. The numerator and denominator equal to 0. So yeah, how do I find the derivative? What rule am I going to be using?
Quotient rule.
Quotient rule. What is quotient rule again? I'm going to write it up here.
Low d high minus high d low over low low.
All over Lolo. Yep.
Oh, that's why. Heaven backwards, of course.
And yeah, now you guys are still telling me what to write?
X minus 1 times 2x minus x minus 1. No, x squared minus 1, I bet. Times 1. All over x minus 1 squared.
Quantity squared. And again, never FOIL these out, because it just makes it harder. Perfect. So we have f prime, and Ben told us the next step. Can you repeat it again, Ben?
Set f prime of x equals 0.
All right. And that will only do half of it, though, because that'll be setting the numerator equal 0.
And then set the denominator equals
Perfect.
0.
So our first half where f prime equals 0, that happens when all of this stuff is equal to 0. So that's at x minus 1 times 2x minus, actually, I guess I'll keep writing it out because you're probably already copying this down. We probably,
I'm not.
Were you
Quite
thinking
certain.
about taking out the x?
I was thinking about just foiling or distributing this and making this all into one expression.
So it'd be 3x squared.
So this one would be,
2x.
oh, you're already, I think you might have made a
Oh,
mistake.
so it'd be just x squared.
Just x squared, yep. X squared, and what else?
Minus 2x.
Minus 2x, there it is, and
Plus 1.
plus 1, there it is. Okay.
It's not minus 1?
Yeah, so you have a double negative. The negative
Oh.
distributes into both the terms. So that's the numerator is set equal to 0. I
You
can
have to factor that.
factor that into what?
The x method?
You can do that, but you should be able to just see this in AP Calculus.
Mm-hmm.
What does that factor into?
Negative x minus 1 squared.
There it is, x minus 1 squared. Perfect, and that's still being set equal to 0.
So
That's equal.
There it is, x, the lag, x is equal to 1. Perfect, and we have to do the other half now. The other half is denominator
It's also x equals 1.
Mm-hmm.
f prime
Wait.
d and e. So that's for the denominator set equal to 0,
How could it be?
where x squared minus 1, all of that is set equal to 0. Therefore, x is equal to 1.
How can it be both 0 and? Oh, it's just that it's not.
Well, if you think about it, if you were to distribute the numerator in the beginning, it would all f prime of x would all equal.
Close. It's not just 1, it's x plus 1, right?
Yeah.
Yeah, so if you saw that from the get-go, if you would have factored the top and then canceled out with the x minus 1s, you'll just have an x plus 1 on the top. This is really the graph of x plus 1, where you have, what is this going to be, a whole gap, infinity, discontinuity, some sort of discontinuity, because you have this guy. Do you remember what type of discontinuity that's going to be, or what it's going to look like? Whenever you have the top and the bottom that cancel each other out, that's going to be a removable discontinuity. So asymptote is where the denominator doesn't cancel out.
The extra part.
Yeah. And then the removable discontinuity is where you cancel both the top and the bottom out. So this is going to be a removable discontinuity at x minus 1. And aside from that, it's basically going to be a straight line x plus 1. And you know how to graph that from Algebra 1 in your first month, hopefully. All right, so let's go ahead and graph our removable discontinuity at x equals 1, where f prime does not exist. So that's going to be 1. And what are we going to label this thing as?
CV.
CV, there it is. All right, we need to find, and I guess we should be keeping a list of all the things that we're doing. So we just found f CV. That was at where?
X equals 1.
All right, next two things that we're going to find are what?
F increasing.
F increasing, F decreasing. How am I going to do that?
You plug in your
What point should I plug in?
2.
And
0.
0. Okay, when I plug in 0 on the left-hand side, what do I get?
Positive.
Positive. Do Arrow and Ben agree? We'll go with it, yeah. It's going to be positive because this is going to be negative times a 0. So this whole thing is 0 when I do that. When I plug in 0, this is going to be 0 minus 1 times 1. This is going to be a negative 1. Positive on the top because negative, negative 1. So positive 1 on the top. When I plug in 0, anything squared is always going to be positive. So that's the reason that's positive. When I plug in 2, and this is going to take a little bit longer. When I plug in 2, is it a positive or a negative for the derivative? So you're plugging in 2 to each of these.
It's a positive.
It is positive, yep.
But what about the negative distributes to the x squared?
Yeah, so let's see what happens. So when I do 2, 2 minus 1 is 1, so that's a positive here. 2 times 2, that's a positive here. When I plug in 2, 2 squared is 4 minus 1, that's a positive times a positive. So it's going to be a bigger positive minus a smaller positive. So this whole top is going to be positive. And we know that anything squared is going to be positive, so it's positives all the way through. The answer is positive. The other reason that I know that this is positive is because I told you what this graph looks like. It's the graph of x plus 1, which looks like that. The slope of that is always positive everywhere, aside from that one removable discontinuity at x equals 1. So a few different ways to think about it. But we know because the left-hand side has a positive test point, this interval over here is therefore
Increasing.
f increasing, and this one is also positive, so this is also f increasing. There it is. Whew. All right, so f is increasing on what interval?
Negative infinity to 0. I mean 1.
Oh.
And then union.
Oh, yeah.
2 infinity.
1 to infinity. And how do I write that with inequality notation in case I want to do that?
X does not equal 1.
There it is. Yeah, that's the best way of doing it.
Oh. It's on the thing over there.
Yep.
But I wouldn't know. Stared at it.
Yeah, but you Definitely have it now. All right. F decreasing. What do I put for that?
None.
Yeah, none. Just do a line. All right. What are the next three things that I need to find? The new things from the notes today.
The relative extrema and then the minimum and maximum for F.
F min, F max. All right. What are those things? Where's the F relative extrema? Yeah, none. Why none? Someone else aside from Ben, because I think Ben understands it.
Because it's does not exist in non-zero.
Okay, so it doesn't exist at not zero,
One.
at one.
At, like the CV is it does not exist in a zero.
Okay, you can have something that does not exist that can still be a relative extrema though.
Is it because it's linear?
Not because it's linear. Okay, let me go back. What's the definition of F relative extrema?
Oh, when F prime sign changes.
And then the sign went from positive to a positive.
It doesn't change.
Doesn't change. That's why it's none. Perfect. Where's the F min?
There's no-
Also,
Where's the F max? You can't have any F min or F max because you didn't have a F relative extrema. Those are both subtypes of nothing. Yep, so they're all blanks.
Can the homework be that easy?
No.
never that easy.
All right, that concludes the notes. Are there any questions before we write our summaries? All right.